Hi Math 20, let's check out 8-2, 33 through 36. So we're going to go backwards. So this really tests if we figured out the section or not. So it's going to be hard the first time, but this is really testing us. So I think the first one's the easiest. When we have circles centered at the origin, that's just r equals a number. So what's the radius? So we start at 0, 0, we go 1, 2.5. So that would be 5 halves because we prefer those improper fractions. We don't really use decimals or mixed numbers in calculus, so we're going to get in that habit now. So I did that one a little fast. I think it's the easiest. 34, 35, 36 are a little trickier. So 34, it looks like we have a circle, but with a different center, right? It goes through the origin. Oops. Right? It goes through the origin, but it's not centered at the origin. So we'll look through our notes and try to figure out that shape. This one looks like it has like a little dimple, right? So we'll remind ourselves of that shape in 35. And then this one has the little loop. So let's go peek back at our notes and see if we can find these shapes, and then that'll help us figure out the general equation, and then maybe we'll plug in some points to try to figure it out. All right. So we have cardioids. It wasn't quite a cardioid because we had the dimple right? The cardioid goes in the middle. So we didn't have a cardioid. We had this shape right here. So we had these two shapes as equations. So I'll bring that over. Yeah, that looks like 35 and 36. So that'll help us in a second. Just putting this for reference. So these will be in the form a plus or minus b cosine or sine theta. And then let's see. Let's find the other shape. It was a circle. Where do we find those circles? I think those were earlier. Nope, they were later. So I'm just searching through my notes for those circles that aren't centered at the origin. There they are. So this is what it looked like we had in 34. All right, so let's start with 34. All right, so 34, since we have it on the left side, it's going to fit this. It looks like we have r equals a cosine theta. A will be negative because we're on the left side. That's what makes it reflect to the left side. And then how do we figure out A? A is the diameter. So diameter is 1, 2, 3, 4. So this would just be r equals -4 cosine theta. So diameter is the A. Negative makes it reflect to the left side. And if you wanted to check your work, you could plug in a couple points. So theta and r equals -4 cosine theta. 0, what's cosine of 0? 1, so we get -4. So that makes sense. That would be right here. Because here's 0 and we reflect. Let's just try one more. Maybe pi over 2. Pi over 2 would be 0, so we would just come back to 0, and so that's probably why we land back here. So just making a loop. And so if you wanted to find some angles in between just to confirm, totally do that. But by using our notes, we can definitely get a guide of what we should be choosing. But if you wanted to plug in pi over 4, you could try that. Just to plug in something in between to maybe convince yourself of these in-between points. -4 cosine of pi over 4. What's that? -4 root 2 over 2. So -2 root 2, which means pi over 4 is here, but then it's just going to reflect to the other side. So that's why we have the circle on the left side. All right, let's try 35 and 36. So 35, it looks like we have a dimple one. So that means for 35, I'll show you how to decide between those two. It looks like my A over B is in between 1 and 2. So how do I decide if it's sine or cosine? So let me go back to the cardioids. The cardioids actually kind of told us. So this tells us. So we had it on the left side, which means we're going to use cosine, and we're going to use subtraction because, again, that's what makes it reflect to the left, kind of similar to last time. So this, for 35, we will have A minus B cosine theta. And then if you're not sure about the minus, let's just do plus, and then when we solve for A and B, we will find that negative number anyway. So we could just put plus or minus because maybe we're not sure. The only reason I know it's cosine is cosines go left and right, sines go up and down. Just like this, right? Cosines are left and right, sines are up and down for all these shapes. All right, so let's see 35. So how can we figure out A and B? I'll just plug in a couple points. So when theta is 0, it looks like we get 1. So what's cosine of 0? Cosine of 0 is 1. So we know A plus or minus B is 1. So again, when I solve this, I'll decide if it's positive or negative. I'm just going to leave it as plus because if it ends up being subtraction, I'll just get a negative value for B. So then we don't have to worry about that. Let's do pi over 2. I'm picking easy points. So pi over 2, it looks like we get 1, 2, 3, 4. So A plus B of cosine of pi over 2 is 4. And then let's see, what do we get? We get cosine of pi over 2 is 0, so 4 equals A. So we're almost there. So then 1 equals A plus B. So B would be negative 3. So that tells me it is the subtraction case. And then let's check. So 4 over 3, yeah, is less than 2, but bigger than 1. So that made my dimpled shape. So for 35, we get 4 minus r equals 4 minus 3 cosine theta. All right, and let's try the loop one. So this will be 36. So 36, we have the loop. I know it's going to be sine in this case because it's vertical, so the sine ones are vertical. So we're going to have A plus or minus B sine theta, and then what do we know? We know A over B is less than 1. That's what makes the loop. So these are a really good chance to test how well you understand this section. So these are definitely a challenge. So let's do the same thing. I'm just going to do again plus. If it's minus, when we solve for B, we'll get minus. And I'm just going to do 0 and pi over 2 again, because those are the two easy points. So it looks like when theta is 0, we get 2. And when theta is pi over 2, we get 1, 2, 3, 4, 5. And we'll use these to solve. So 2 equals A plus B times sine of pi over 2. Sine of 0, because I'm at 0. Sine of 0 is 0, so we immediately know A equals 2. So that's cool. We figured that one out pretty fast. And then for pi over 2, we get A plus B sine of pi over 2. So 5 equals 2 for A plus B times 1. And so we can quickly find out that B is 3. So we get R is 2 plus 3 sine theta. And then A over B is 2/3, which is less than 1. So that makes sense for the loop. So basically the steps are determine the base shape. Right? By knowing the base shape, it makes this a little bit easier. We're not totally guessing. And then maybe just plug in a point or two. I think I needed 2 points to really figure this out, right? To find A and B. You can also guess and check, but that might take a little longer.